Hi everyone, I'm Mike Jacoby from Lucid Vision Labs, and in this video I'm going to go through a step-by-step tutorial on how to get started with the Triton Smart Camera and Brain Builder. I'll be going over how to acquire images, how to start your data set, classify them, export a model, and upload it to the Triton Smart Camera and have it running live. The first thing I'm going to do is download all the software needed. That includes Brain Builder for AITRIOS. You can get this on Sony's AITRIOS developers website. We currently only support Windows, so download either the CPU or GPU version. I'm going to download the CPU version, but if you have a modern NVIDIA graphics card, go ahead and download the GPU version. Next, I'm going to download CodeMeter. Link can be found right here underneath the Brain Builder links. CodeMeter is needed to manage the licenses for Brain Builder, and that includes activating the trial license. So again, we're only supporting Windows at the moment, so I'm going to download the Windows version. I'll be saving all these files to my downloads folder. That takes care of all the Brain Builder files. Now we need to download our Lucid files. I'll head over to Lucid's website and go to the Triton Smart product page. And on that page, I'll scroll down and select the Getting Started Downloads tab. In this video example, I'm going to download the Arena SDK with ArenaView MP and the Triton Smart Support Package zip file. If you already have a previous version of Arena SDK installed, you can install the Arena MP Lite package. In total, I have 4 files: Brain Builder, CodeMeter, Arena SDK with ArenaView MP, and the Triton Smart Support Package. First, we're going to install CodeMeter, so go ahead and do that now. It will extract its files first and then run the installer. I'll be installing it using the default installation settings. And once we're done, we will now begin Brain Builder installation. Extract the Brain Builder zip package and go into the extracted folder and double-click the Brain Builder exe file. This will initiate the installation, and same with CodeMeter, I'll be using the default installation settings. Once that is done, it's time to activate the trial license for Brain Builder. This is activated by double-clicking this BB trial license file right here. It should run the CodeMeter program, and you'll see a pop-up dialog box like this telling you it's successful. Now let's install Arena SDK with ArenaView MP. When presented with the installation profile options, make sure you select Developer. This will install the full package. After a restart, let's open up ArenaView MP and get a quick overview of the files we need to prepare the camera for the first time. Toggle the camera on by clicking the switch on the top left. Quick note, make sure you have defined a working directory. In this case, that directory is ArenaView_MP in the ArenaView program directory. Open up the controls menu here and select Smart Model Installation. And here are all the files we need. Now, because we haven't trained any models yet to load on the camera, we need to install one of these sample models, which is included in the Triton Smart Support Package. So let's go back to our files and unzip and extract the support package files. In the extracted folder is a networks folder that contains 3 sample models, one for each type of model: anomaly, classifier, and detector. For this example, we will load the detector sample onto the camera. In the od_cat_dog folder, we will find 3 files that we need: a bbnetwork.fpk file, labels.txt, and network_info.txt, which we will need to convert to an fbkinfo.dat file in ArenaView MP. So back to ArenaView MP. I'm just going to pull up the logging panel because it will let us know how the file upload goes when we do it. So I'm going to convert the network_info.txt file located in the support package network brain builder od_cat_dog bb output. Select the file, then click Convert. Here we will see that the file was converted and saved into our working directory. Now let's add the rest of our files and upload them. The first two files, firmware FPK and loader FPK, are located in the support package in the imx_files folder. Next, we need to add the network FPK file. This file is located in the sample AI model file in the odcat-dog folder. In this case, it's labeled bb_network.fpk. Then we load the converted dat file we converted just earlier. Here we will go to my working directory, which is the same as my ArenaView MP program directory. And here is the fpkinfo.dat file. Finally, the labels.txt file is back in the odcat-dog folder. I'm just going to clear the log panel so we can more clearly see the upload process. And then let's click upload. You'll see a progress circle next to the camera, the top left, and the logging panel will let you know when each file is successfully loaded onto the camera. The entire process should take a couple of minutes, but in this video I've sped up this part. Once it's done, we are ready to acquire our first input tensor images. So now we're at the stage where we can start acquiring images for your input tensors. Now it's key that you take these images in the same environment that your production is going to be running. You want everything to be as close, if not exactly the same. That means the same optics, the same lighting, the same positioning, and of course the same objects. This will maximize the accuracy of the model when it runs in production. With that, let's acquire some images. But before we do that, make sure you disable your camera in ArenaView MP. Okay, go back to the support package files. In the bin folder are a bunch of files, but the file we want to run is the disp_inputtensor.exe file. A few warning windows might pop up and you'll need to give it permission to run. It will run a script and open up a display window. We can minimize the script window and let's enlarge the display window, which is a live stream from the Triton Smart camera. There are a few options here, but the main one is to capture images, which are captured at the correct input tensor spec. And for that, we just use the hotkey S. Here I'm going to capture a bunch of images, moving my target object into different positions, then saving. You'll see the BMP files being saved in this folder. Now, this is just an example of how you can take the images. You'll want to take way more images than 8. In fact, you'll want to take at least 50 images to get a decent AI model. Let's open up Brain Builder and let's click our first project. Click Create New Project. Name your project whatever you want, just no spaces or special characters. Next, click Create New Dataset. Name your dataset and select detector for your model type. Click on Upload Data. Here is where we add our images. Now remember how I said you wanted to take more images than just 8? Well, in this example, we've taken over 600 images. I'll select all of them and click Open, then Start Upload. Remember, the image upload only happens on your PC and nothing is uploaded to the cloud. Images are first read and processed locally on your PC only. Once that's done, we will define our classes. Click Manage Classes and start entering your object labels. Here I'm going to add chocolate, medicine, and then click Done. Click the image thumbnail to bring the annotation window up and start drawing the bounding boxes around the objects and selecting its label. Then to move on to the next image, you click Save and Next. I'm going to annotate this image, but as you can see, I need to add a new class. You can also add classes by clicking here at the plus sign on the top right. Continue to annotate every image you've loaded into Brain Builder. When you're done, your dataset should look something like this. You'll see a summary of the total number of tags object, as well as a breakdown of how many each object has been tagged. All right, let me just flip through a few images to give you an idea of how everything's annotated. Okay, let's go back to our project summary page and click Train. Now, it's recommended that for a proof of concept and you want something done quickly, the first time you train, just pick Quick as it's the fastest. However, that can still mean that the training process can take a long time, sometimes up to 24 hours. Quick just means that it's faster than balanced and thorough. Now, I have a different project that has already completed training, so I'm going to switch to that. When you're done training your model, you'll get the option to retrain at a different setting. You'll also see a quick summary of the results here. A thorough review of the results can be found by clicking on Evaluate. The main stats you want to pay attention to are the average precision and average recall. Basically, the average precision percent tries to answer the question, of all the objects I detected, how many were correctly detected? And the average recall percent tries to answer the question, of all the objects that exist, how many did I detect? Obviously, you want these numbers as close to 100% as possible. I'd say we're happy with the results, so we'll click Export on the left-hand side and click Download Brain. Brain Builder will export a zip file with the file name based on your dataset title with a -IMX 500 added to the end. At this stage, we will have to do the same thing we did when we uploaded the sample model to the camera. Let's first unzip the file. Once extracted, go into the folder and you'll find another zip file. Unzip and extract that file as well. Now in this extracted folder, you will find the 3 files we need: labels.txt, network.fpk, and networkinfo.txt. Let's switch to ArenaView MP to upload the files. First, toggle the camera on the left-hand side to enable the camera controls. Once again, we need to convert the networkinfo.txt into an fpkinfo.dat file. We'll locate the file within the exported models and click Convert. Select the firmware.fpk file located in the IMX501_files folder in the support package. Do this also for the loader FPK file. The network.fpk file is located in the second extracted zip folder we got from the Brain Builder export. The converted fpkinfo.dat is located in our ArenaView MP working directory. And finally, labels.txt, located back again at our second extracted zip file folder from our Brain Builder export. All files are ready to go. Click Upload. Again, I've sped up the section, but once it's all done, you can simply click the stream button on the top left-hand side. And here the viewer will show a live stream of the camera with the object detection bounding box overlays. There are a few additional options. You can go into the Controls menu and under Image Processing, select Smart Display Settings. Here, you can enable or disable the AI model overlay or adjust the confidence threshold. All right, that concludes our tutorial on how to get started with the Triton Smart Camera with Brain Builder software. Hopefully you found it informative. Thanks so much for watching and stay lucid.